Hi everybody, welcome to another video in Math 1332, section 8.4, compound interest. So this is a little more complicated than the previous section, and some of the calculation we have to rely on the calculator, that calculator in particular. Alright, now let's look at this one. Suppose that $5,000 is invested for 3 years at 8% interest. Find a simple interest. Well, that's easy. That's from the previous section. I equal to PRT 5,000 interest rate 8%. Let's write out P 5,000 interest rate 8% for 3 years. So that's 1,200. Right. Now, but in reality, have you ever think about for investment? If we sit that money for 3 years, why don't we get the money after 1 year? Because after 1 year, it generates some interest, and then we put it back in the bank. That will generate more interest that way, right? So why don't we do that? Do it. Let's look at this case. For year 1, now we only calculate the interest here, right? So the interest is equal to PRT. This is only for 1 year. So it is for 1 year only. Right, that's $400. So in the first year we have $400 interest. But now we go to year 2. Now, what do we do with the 400? Of course, we can take the 400 and we put it back in the bank. So this time it is I equal PRT. But now the money after year 1 is no longer 5,000. We earn some interest after that. And we invest the interest after 1 year in year 2. Of course, times 1. So that plus 5,000, that's 5,400 of course. That times 0.08 432. So after year 2, for year 2 alone, we earn 432 interest. For year 3, now we have the 5,400 and then 432. And so pretty much we have that is the amount after 1 year plus that is the amount after the interest for year 2, and we have that, and we take that amount times 0.08 and we have 466.56. So in year 1 we have that much, year 2 we have that much, year 3 we have that much. So the total interest for 2 years, for 3 years, are 400 plus 42 plus 466.56. So the interest is equal to 1298.56. Of course, that is more than the 1200 we have for the simple interest. Of course, in terms of investment, we should do that. So bottom line is, the more often we withdraw the money and take the interest at that moment and keep investing, that will be better. So, and then you say, why don't we, instead of withdraw at the end of the first year and at the end of second year, and why don't we just withdraw every month? Because each month it generates some interest, and then we just invest that every interest we get along the way, we should put that back in the bank and generate more interest, right? And that's, in fact, that should be the case. So that gives us the formula for this is equal to future values, the compound interest principal times 1 plus r over n over nt. The only thing different here is that we have n. Where's n? All of the quantities stay the same except for the number of times per year. So that is n. So if it is monthly, meaning 12 times a year, if it is quarterly, like this, 4 times a year. And so in that case, we calculate the future values. The future values subtract the principal, give us the interest. Right, now let's look at the first problem. How to find the interest of $7,000 compounded quarterly 3% for 5 years. Write down everything we have. So we write out all the information given here. So find the interest. So that's what we're looking for, the interest. The 7,000, that is the principal. Quarterly, that means n is 4 times a year. 3% interest. For 5 years. Right, so we have everything. Just put in the calculator. Times. Oh, let's try the formula first. Right. Now, if you use this calculator, I recommend we use the take advantage of the fraction alpha y equal n. So we have a fraction. %, 4 times a year, close. This is the power to the 4 times 5. Of course, that's 20. 4 times a year for 5 years, so that's 20. So that's what we have. 8,128, and then round to the penny, 29. And we subtract the interest. I'm sorry. And then we find the interest is the future values minus the principal. So originally we invest 7,000, and after 5 years we have 8,128.29 minus 7,000. So we have that much. So that's the interest. Right, next, find the interest on $11,000 compounded daily at 5% for 6 years assume that there are 365 days in a year, right? So write out the principal 11,000 compounded daily, %5 for 6 years. So A equal to P times 1 plus R over N over NT. Principal. The rate over N, the power 365 for 6 years. Right. One plus 0.05. If we don't want a fraction, we just do that. Right? And then the power. If your calculator don't do that, make sure there's a parentheses of everything on the exponent. You put the parentheses around that. Right, we have 14,000. $848.14. Of course, if we put that as a fraction form, right, should be the same. Right, so that is, we just use the formula there to calculate the interest. Right, next, can we use that formula to find time? Like I said, how long does it take to pay off some amount? Well, the bad news for that is no, because we require some higher level of math to do that. So in that case, we have to use a calculator. So this features is in the application only for this TI-83, TI-84 calculator. When you hit apps, that's the Finance app, the TVM solver. So I'm going to write out this note and then we go back to the previous problem, check a few things. Right. So let me just do that again. Second mode is to get back to home screen. Second mode. First hit apps. And then the first option there is one finance, so hit enter. And then hit 1 again for TVM solver. So with that we have N. I'm just going to say all of those. And then PV, PMT, and future values. So present values, future values, and payment. And the last two will be the same. So I'm just going to write in one line. And we keep that at the end of the period. So that should be it. Right, let's write out the important things about this. So N. Now this N is, the capital N is different than the little n. So this N is actually equal to little n times T. So how many times is a year and how many years? So this is equal to the number of period. How many times a year times year. That interest rate percent. So this we type the percent, we not type the decimal here. And this is rate for 1 year. The middle three here, That is the important things here. The note for that. In this case, 1 is positive, 1 is negative, 1 is 0. It's always like that. So 1 positive, 1 negative, and 1 0. Right? And then positive is with our perspective, receiving the money. And negative is giving away, so out of the pocket. And the last one is just n, how many times this is compounded in a year. Right, let's see how it works. Go back to the previous problem. Let's look at this one. Now use a calculator. Right, so in this case, what is n? Sorry. This problem compound quarterly, so 4 times a year for 5 years. So that should be a capital N. 4 times a year, 5 years. The interest 3%. The present values, what we invest now is $7,000. It is an investment, so it is out of our pocket. Negative $7,000. The payment, after we invest, we do not put any money in the bank, so that will be 0. The future values, we don't know, but it is 4 times a year. Right, now we go highlight the future values. If we want to solve for anything, highlight that, hit alpha and enter. Now that will be the amount of the future values. Of course, that should be exactly what we get, right? So the middle 3, 1 positive, 1 negative, and 1 0. And in this section, the payment is going to be 0 because we only have the future values or the principal present values. And then 1 positive, 1 negative, and the rest will be easy. Right, now we're going to use that to find time here, because without this calculator, we need a high level of math. So, let's figure out what we have here. N equal to interest rate, present values, payment. Now we know it's going to be 0. Future values, period per year, compounded period a year. Right, now put everything in here. Right, and how long? So the question asks for how long, so this certainly we don't know n. Interest rate 3%. Just put 3. Compound monthly, so that is 12. And if you want to save $5,000 before buying the first new car, and you have $3,000 right now, so invest $3,000 and hope to get $5,000 later in the future. Right, so we fill out everything here. The only thing left to do is solve for that. So every time we want to solve for anything, highlight that and hit alpha and then enter. Right, so here original, I don't know what it is, just leave it blank or just type 0. We cannot leave it blank, so I have to type 0. Interest rate 3%, so that's good. Present values, we invest $3,000. Payment, there will be none. Future values, hope to get 5,000, and 12 times a year. The last two always the same, so we just need to put one of them. Right, now just go back on N and hit alpha, enter. So that gives us 2 and 4. So what's that? So that means 2 and 4 payments, 2 and 4 period. And if we take that number, just do right here, divide by 12, because 12 times a year will give us, divide by 12, give us 17,000, 17 years. So it takes 17 years to go from 3,000 to 500. from 3,000 to 5,000. So that's why usually we do the car loan instead of saving money like that. Right, so pretty much just that application. Next, if you owe 1,400 on a high interest credit card, 21% compounded monthly. By the way, 21% is a typical credit card rate usually, but it is usually compounded daily or even shorter than that. How long will it take the amount to double if you don't make any payment? Well, let's find out what we have on that app. N equal to interest rate, present values, payment, present future values, and that. Right, one thing though, don't make any payment. Right, and how long will it take? If the question asks for how long, that means we don't know n. The interest rate, 21% monthly. Right, now we own 400, so they're going to give us 1,400. So we just spend that on a credit card. So that's positive. But eventually we have to pay it back. And let's say we pay it back. Whenever we pay it back, it's going to be double this amount. Let's assume that, of course, if we don't make any payment, there will be a lot of penalty. But assume that there's no penalty here. Just strictly the interest. So we have to pay it back 2,800 without any penalty. To pay back our pocket, that's the minus. Right, so we just go back here and then solve for, so alpha, enter. So interest rate 21%. I'm just going to leave the n there, of course we're going to solve for that later. Present values, we got 1,400. Now, don't make any payment, but we have to return double amount of that. So 1,400 times 2, 2,800. And yeah, 12 times a year. So that's good. Now just go highlight here, alpha, enter. So I have 39. So what is that? So 39.95. So that is the number of period divided by 12. Go way down here, divide by 12. So that's 3.3 years. So that's about 3 years and 4 months to go that fast. Right. So the interest rate, because it's a lot higher than the others. The others take 17 years, is not even double. On this one, it takes only 3.3 years and it already double. So the interest rate make a big deal of this. Right, like I said, we won't be able to do this without a higher level of math. So that's why we can only use a calculator here. Right, the last part of the section is effective rate or called the annual yield. So given by this formula. And there's a typo here, that is t is equal to 1. So in that case, we just ignore the t. So that is the formula. So essentially, the effective rate, this is the simple interest rate equivalent over 1 year. So let's say we have like 21% interest rate is compounded monthly. So we say, what is the equivalent to that if it is a simple interest for 1 year? So that essentially is the effective rate. So effective rate is essentially the simple interest rate for 1 year equivalent to the compound interest in 1 year. Right, so pretty much that's that. Let's look at some example. Find the effective rate for 4% weekly. Right, so we start with the formula. Right, so 1 plus 0.04, that is the rate. Weekly, let's say the 52 weeks in a year. Right, second mode, get back to home screen. Right, we have that. Right, if we change to percent, that is 4.08%. So that is the effective rate. So that means if we have the simple interest at 4.08%, this is the same thing as 4% interest compounded weekly. Right? So we find the equivalent of the simple interest with the compound interest for 1 year. Right, now next, what saving account is better? 6.2 compounded daily or 6.25 compounded semi-annually? Well, so what we calculate here is, of course, is the effective rate for both of them. Whichever give a better rate, that will be the better saving account. Let's just write out 6.2% compounded daily. Or 6.25 compounded semi-annually. Effective rate right. So 1 plus by the way, that rate is 0.062 daily, 365 days in a year. Zero point 0.06396. Right, because that's 6.396%. We're just going to leave that. We can just compare the decimal here for the other case. So 1 plus the rate, so 625 over, now semi-annually, so 2 times a year. So 0.06348. Now we compare, this is 0.6396, so this is slightly better than that. Slightly better. Of course, if we make investment a very small amount, that doesn't matter. But if we make a very huge investment, every little thing counts. So this is 6.39%, this is 6.34%, so that is slightly better. So we should go with this. And with that, we finish section 8.4. As always, Thank you for watching and see you in another video in Math 1332.